sa lab activity na nakalimutan ko kasi i-check yung group assignment. So, ako na bahala dun. Okay? Ayan, so, thank you sa nag-record. Nakalimutan ko. Okay? So, yun lang. So, all home lab activities are posted in Canvas together with the quizzes. They will open at the time indicated here. So, basically, yun na. So, we are ready for the midterm period. Okay? So, I wish you all the best. Okay? So, ano na gagawin natin ngayon? We are done with chapter 3. So, meaning we can proceed now to chapter 4. This is the last chapter and probably the most important chapter in Anachem. Okay, so this is about acid base and solubility equilibrium. This is an application of whatever you have learned in equilibrium. Okay, sa lecture, apply natin siya dito. Okay, so with that being said, I guess we can start na. So, so for the next 2 weeks, we'll cover acid-base equilibrium and solubility equilibrium. But if in case na maaga tayo matapos, then that's better. Okay? So, what are the subtopics that we have to learn? So, of course, we'll define acids and bases, and then the properties of water. Why is it neutral? Let's talk about that. And the strengths of acids and bases. And probably we'll have an application of your equilibrium topics in the context of acids and bases. Okay. I'm not sure if we will be able to cover these topics. Okay. While this one naman, this will be done asynchronously. Okay. So asynchronous itong balak namin dito so that you will have more time to review on your own. Okay. So ako yung gagawa ng video dyan. Okay. So let's just see kung saan tayo matapos today. But hopefully we can cover these subtopics. Okay, so again, we will apply the knowledge of equilibrium in acids and bases. So that means if time permits, we will have ice table calculations. Okay, but anyway, so before we even proceed with the equilibrium applications, let's talk about acids and bases muna. So let's have a review of Gen Chem. Okay. Well, last year, you are familiar with this slide, right? Nasa PowerPoint to last semester. So, we said that acids are generally sour. Yung suka, maasim. Ano pa ba yung maasim? Yung citrus fruits natin, they are sour in taste, because of the acid that are in there, And also, we know that acid can react with metals to produce hydrogen gas and carbonates to produce carbon dioxide gas. Okay? So, one example is, kunwari, sa bahay ninyo, you add acid to your baking soda, okay, or baking powder. Pag nilagyan mo yun ng acid, ano nangyayari? Parang bumubula, right? Okay. So, pwede siya gawing parang volcano experiment. So, yan. The bubbles there are actually carbon dioxide gas. And yun yung role ng acid. It can liberate carbon dioxide from your carbonates. And for metals, kaya niya sirain yung metals. And that produces hydrogen gas. So, yan yung mga concerns ng acid rain. Diba? Kapag may acid rain kasi, nabasa yung metal, magkokorrode madali yung metals. So, yan. Okay, so those are the characteristic of acids, So I think familiar naman tayo sa mga characteristic na yan. For bases, they are generally bitter, mga mapapait. Okay? For example, the alkaloids, in plants, familiar ba kayo sa alkaloids? So alkaloid is a phytochemical, okay, that are basic na alkaline alkaloids. No? Yan. Mga mapapait sila. Okay? So sometimes they are acidic but some of them are basic. No? Okay? So yan yung mga alkaloids. Sila yung mga present sa mga napapait na nasa halaman. Okay? And even in caffeine. Okay? So they generally have bitter taste and they feel slippery. Okay? So for example, yung ating sabon sa bahay, 'di ba, you did your experiment last semester wherein you were able to create soap, no? By mixing oil and sodium hydroxide, no? Or drain cleaner. So yan. So ganun yung nangyayari sa bases, no? So, they can react with fats to produce slippery substances, no? Such as soap. Okay? Tsaka pag nadilaan mo yung sabon, di ba, naliligo ka, tapos may something na nadikit na sabon sa mouth mo. But you can taste the bitterness. Yan. So, that is basic compounds. Okay? So, yan. So, those are the general characteristic of acids and bases, and I think everyone's kind of familiar with it, with those naman. Na? Okay? But, in chemistry concept, no, you don't have to taste all the liquids. Of course, bawal yun. Kasi baka mamaya, kunwari face-to-face to, no? Gawin nyo, classify this as acid or base. Mamaya nagulat ako, dinidilaan yung mga liquids. So, ganun. Okay. Kasi hindi dapat ganun. Okay. So, we know that these are the characteristic of edible acids and bases. But, how can we tell if a substance is acid or base, no? By just looking at its formula, no? Paano natin masasabi that this is an acid, this is a base, no? By just looking at the formula, by just looking at the structure, okay? So that will be our first task for this session, no? So let's look into the definitions of acids and bases so that we can have an idea on how can we distinguish acids and bases, no? By just looking at the structure or the formula, okay? So let's do that. So there are many chemists, no, that defined acids and bases. No? Of course, as time progressed, the understanding of chemistry increased significantly. So that's why for every definition, pahirap ng pahirap yung kanilang concepts. But even though almost 10 yung definition ng acid and bases, at least 10 definition yung acid and bases, we'll just talk about 3 of those 10. Okay? So yeah, so let's talk about those 3, and those are Arrhenius, Bronsted-Lowry, and Lewis definition. Okay? So Arrhenius definition, you are familiar with this one because we discussed this last semester. For Arrhenius, an acid is a compound that releases hydronium ions when it dissociates. While for bases, it produces hydroxides, no, when it dissociates. Okay? So, ganun lang kasimple yung idea ni Arrhenius. Kapag acid, your cation is H+. Kapag base, your anion is OH. And those H plus and OH are released, no, when they are dissociated. Okay? When you say dissociated, they separate into ions, no? Because probably they are in aqueous solution. Okay? Pag nilagay mo sila sa tubig, nagiging ion sila. Okay? Naalala pa ba yung Arrhenius definition? So, yan. Okay? So again, Arrhenius definition is very simple. For acid, that's H plus donor. And kapag base, that's OH donor. Okay? Here are some examples. You have your HCl, hydrochloric acid. It is defined by Arrhenius as an acid because it produces hydronium ion. Okay? May na-produce kasi siyang H+. Kaya siya Arrhenius acid. While for sodium hydroxide, which you used last semester in making soap, ayan, it produced OH minus. Ganun lang siya ka-simple. Okay? Ganun lang ka-simple. Okay, this thing is new to you. Okay, that's why I need to focus on this one masyado. Okay, so let's talk about Bronsted-Lowry definition. Okay, sino sa inyo yung nakakakilala kay Bronsted-Lowry? Especially yung mga nag-STEM sa inyo. Naalala pa ba si Bronsted-Lowry? Or hindi na? I think hindi na. Kinalimutan niyo na siya. Okay, so let's talk about Bronsted-Lowry. Okay, si Bronsted-Lowry kasi marami siyang problem sa life. Okay, katulad natin. For example, sodium carbonate. Is this an acid or a base? 'Di ba? May OH ba dyan? Wala. May H plus ba dyan? Wala. So, we cannot tell. 'Di ba? Hindi natin magagamit yung Arrhenius acid-base definition kasi wala siyang H plus. Wala siyang OH. Pero, when you submerge it in your pH paper, pag ginawa nyo to sa bahay, malalaman nyo, basic pala siya. The question is why? Diba? Pala siya naging base. It doesn't produce H+. It it also don't produce OH-. So, weird, right? Diba? So, parang weird na siya ay basic, pero walang H+, pati OH. What else? Ammonia. Okay. Have you smelled ammonia before? Meron na ba nakaamoy ng ammonia dati? Or wala pa? Ito yung pinapaamoy kapag ikaw ay nag-pass out. No? Pag nahilo ka, gaganon yan sa ilong mo para mag-pass out talaga ang kaluluwa mo. Ayan, so si Shindle naamoy na. So, mabaho, di ba? Okay? So, actually, yung ammonia, bukod sa mabaho siya, it is basic din pala. No? Pero, did it produce H+? Did it produce OH-? I cannot tell, no? They're just looking at the formula. Okay? Hindi natin masabi. Pag tinignan mo yung formula, you don't know. So that's why Bronsted-Lowry created the new definition. By the way, dalawang tao yan, si Bronsted pati si Lowry. Okay? So, gumawa sila ng mas broad na definition than Arrhenius na. Kasi si Arrhenius, it's just limited to H plus and OH. But Bronsted and Lowry wants to know how your ions interact in aqueous solutions. Okay? So, tinitignan niya kung ano nangyayari when it is in aqueous solutions. So, let's look at some examples. Sorry. So, for example, here, let's look at HCl. When you add HCl to your water, what happens? It produces hydronium ion and chloride anions. So, ano ngayon? So, ganito. Ang definition kasi ni Bronsted-Lowry is this, no? Kapag ang iyong substance, siya yung nag-donate ng hydrogen, okay? So, according to the Bronsted-Lowry definition, okay, siya daw ay acid, no? So, that's Bronsted-Lowry acid, okay? Hindi yan yung Thai series ng mga BL. So, Bronsted-Lowry acid daw siya. Kapag siya daw yung nagbigay ng hydrogen atom, it is an acid according to Bronsted-Lowry. Pero kapag siya naman daw yung nag-accept ng proton, siya naman daw yung base. Okay? And actually, itong redefinition is very significant, no? Kasi you don't need to look for OH anymore to classify one substance as a base, no? For example, ito wala tong mga OH pero base sila. Why? Because probably they accepted the H, no, from other chemicals, no? Okay? When they react with one another. Okay? So, ganun yung parang idea ni Bronsted-Lowry. So, you don't have to look for OH anymore. All you have to monitor is which atoms or which molecule accepts or donate protons. No? Kapag siya yung nag-donate ng proton, siya yung acid. Kapag siya yung tumanggap ng proton, siya yung base. Okay? So, very significant to, no? Okay. So, look, na. Yung HCl, we know that it is acid, right? Kasi it produces H+. And it is evident naman na. So, if you look here at the other side of the equation, ito yung kapartner niya. Okay? Paano ko nasabi yan yung kapartner niya? Kasi para silang may Cl. Okay? So, if we look at its partner on the other side of the equation, nabawasan siya ng H, no? Kumbaga, nag-donate siya ng hydrogen. So, meaning, HCl is indeed an acid, no? So, kanino niya dinonate yung H? Kay H2O. So, if you look at H2O, yung H2O ngayon, nadagdagan siya ng H. So, meaning, it accepted the hydrogen. Sorry, mali ako dito. So, yan. So, si H2O, nadagdagan siya ng hydrogen, meaning it accepted the proton. So, it is defined as the Bronsted-Lowry base. Okay? So, parang ganun lang ka-simple yung definition ni Bronsted-Lowry. No? So, sabi nila, you don't need to look for the OH. All you have to do is to monitor where the hydrogen is going. If the hydrogen is removed from the molecule, meaning it is donated. So, siya yung acid. If it increased in terms of number of hydrogen, that means siya yung acceptor ng proton. Or in other words, siya yung base. So, ganun lang ka-simple. And that rev definition is very significant, no? Grabe din ang effect niyan sa chemistry. Okay? Because with the Bronsted-Lowry definition, we were able to classify more and more substances as acid and base. Okay, let's take a look at ammonia. Okay, ito may typo ako dito. Hindi ko na paghiwalay. So anyway, so let's take a look at ammonia. Okay, so bakit siya basic? Kasi basically, ganito pala nangyayari sa kanya. When it is reacted with some chemicals, okay, what happens is that it gets the proton of the other molecule. Okay? So, mapapansin mo, yung HCl, idodonate niya yung H niya kay NH3 so that it will become NH4. No? So, ibig sabihin, since ammonia accepts the proton of the other molecule, siya pala yung base. Okay? So, siya yung Bronsted-Lowry base. Okay? And si HCl, as always, acid naman yan parate. Okay? So, yun. So, kumbaga, ito yung nakatulong sa chemist, no? Para malaman yung acidity and basicity of compounds. Okay? So, nakita niyo yung big difference. Big difference na yan para sa amin. Kasi kay Arrhenius, basta may OH. Paano naman yung walang OH? How will you classify them? So, sabi ni Bronsted-Lowry, tignan mo kung sino yung naglabas ng H at sino yung tumanggap ng H. Pag yung molecule na tanggalan ng H, siya yung acid. Pag siya yung nadagdagan ng H, siya yung base. Okay? So, ganun lang ka-simple. Also, what's noticeable with the Bronsted-Lowry definition is that you can see that there are pairs, no? Parang may mga pares, no? Parang before, after. Okay? So, parang ito before, ito yung after. Ito yung before, ito yung after. So, kumbaga may pairs, no? We call them the conjugate acid-base pair. Okay? Conjugate meaning yung parang before and then after. Okay? Parang yung counterpart niya sa other side of the reaction. Okay? So, they are related in a manner na pare-parehas yung atoms nila, except that yung isa nagdagdagan ng H, yung isa nabawasan ng H. Okay? So, we have here another reaction of ammonia and water producing ammonium ion and hydroxide anion. As you can see here, no, si ammonia before tatlo yung hydrogen niya. Pero pagdating dito sa other side of the reaction, apat na yung hydrogen niya. So, ano yun? Is it a Bronsted-Lowry acid or a Bronsted-Lowry base? So, tatlo yung hydrogen niya, tapos ngayon naging apat na. Ano kaya tawag sa kanya? Bronzed lauryl acid o bronzed lauryl base? Look at the definition and then give me the answer in the chat box. Ano kaya nangyari kay ammonia dito sa reaction na to? Is it an acid? Is it a base? Just look at the number of hydrogen. Okay? So siya ay bronzed lauryl base, correct na. Kasi tandaan, kapag siya ay proton donor, yan ay bronzed lauryl acid. Kapag yan ay proton acceptor, siya ay bronzed lauryl base. Okay? So, yan. So, nadagdagan siya ng H. So, ibig sabihin, totoo nga na basic compound yung ammonia. Okay? So, yun yung gusto ko gawin niya sa laboratory niya, na. So, you just don't write the formula, na. You analyze what happens when it is in liquids, na. Does it produce conjugates? Okay. Does it accept the hydrogen? Ganun. Okay. So, yung kasi mag-explain bakit sila acidic, but sila basic. Okay. So, ammonia, as you can see, nag-increase yung kanyang hydrogen from 3 to 4. So, it accepted the proton, meaning it's a bronzed lauryl base. Okay. So, yan. Meanwhile, yung water, what is water? Is it an acid or a base? How about water? Ay, yung isa, base. So, meaning yung isa ay base din ba? Ano kaya si water? Kung ito ay base, ito ay base din ba? Ito ay ano? Ano si water? Acid. Okay? Hindi pwede parehas base, ha? Okay. Walang mangyayari doon pag parehas base. So, kailangan yung isa acid, yung isa base. And that can be confirmed by just looking at the formula now. So, originally, you have H2O, dalawang hydrogen, isang oxygen. However, after the reaction, you have the OH, no? So, yun nga. So, acid talaga si water. And then, si ammonia ay base. Ngayon, si bronzed lauryl, gusto din nila pangalanan yung partner nila. Okay? Yung base, yung kapartner ni base, gusto niya lagyan ng pangalan. Si acid, gusto niya rin bigyan ng pangalan. So, ano kaya tawag sa mga pangalan na yun? Okay? So, sabi nila that when you have a bronzed lauryl base, ang tawag sa conjugate niya ay conjugate acid. Okay? Yes, acid yung tawag na sa kanya. Meanwhile, yung acid naman, ang tawag dun sa kapartner niya on the other side ay conjugate base. Okay? Bakit naging ganun? Ba't naging baliktad, no? So, kanina acid, tas ngayon naging conjugate acid. Kanina acid, ngayon naging conjugate base. Bakit baliktad? Kasi, look at the arrow. It's reversible. Okay? So, meaning, pag nag-reverse yung reaction, they will reverse the role. Okay? So, yung base dati, siya na ngayon yung magiging acid. Tapos yung acid dati, siya na ngayon yung magiging base. Okay? So, yung dahilan ba't nagka-switch sila ng pangalan is because of the equilibrium arrow. Because, if you do the reverse reaction, this one will donate the hydrogen. Okay? So, siya yung kukuha ng hydrogen. Okay? So, si water yung kukuha ng hydrogen. So, siya yung magiging acceptor ng hydrogen. Kasi acid, si ammonium ion, siya yung magre-release ng H. Pero baliktad yung reaction, keep in mind. Kaya tawag dyan, conjugate. Okay? Medyo confusing lang siya at first na. Pero baliktad kasi meaning ng conjugate. That's why the terms also flips. Okay? Sige, clarification. Yung kasi yung parang very definition ng conjugate in the opposite manner. Okay. or sa kabaliktaran. Ganun. Okay? Sige. Wait ko yung clarification. If we originally stated that the right side po, yung NH3H2O, na po, yung conjugate terms, ay, ano ulit. Siguro I need more clarification then. If we originally started with the right side, okay. So, kunwari dito ka nag-start, no? So, gusto mo pabaliktad. Tama ba? Okay. So, kunwari, pabaliktad yung reaction. So, tignan mo naman na yung point of view nila. So, kung makikita mo, if we are going to produce the left side, this one needs to donate the hydrogen. Okay? So that you will produce this. However, because the reaction is reverse, we need to add the term conjugate. Okay? So, siya yung acid, pero in reverse direction. That's why we call it the conjugate acid. Okay? So, basta yung reaction pabaliktad, lalagyan mo ng term na conjugate. Okay? Because if we look at the opposite direction, ito ngayon yung kailangan maglabas ng H. Tapos ito ngayon yung tatanggap ng H. Diba? Pero, affix the term conjugate kasi opposite yung direction. Okay? So, okay. Okay ba yan? Okay, sige. Don't worry, we have more examples pa. Okay? So, yan ha, basta lagi tandaan, ang term na conjugate is in the opposite direction or in the opposite sense. Parang yun yung idea niya. Pag binaliktad mo yung reaction, the roles will also flip. Okay? But for you not to be confused kung sino ba talaga yung original na acid and base, you have to apply the term conjugate. Okay? So, isalpak mo lang yung term na conjugate. Meaning na sila yung acid, sila yung base if the reaction is reverse. Okay? Okay? So, yan. So, again, just to summarize this slide, yung base dati, pag naging product side, ang tawag sa kanya, conjugate acid. Yung acid dati, pag napunta siya sa product side, tawag doon, conjugate base. Okay? Conjugate refers to kabaliktaran na reaction. Okay? Because they will switch roles when you reverse the reaction. Okay? So, sino yung partner? Ito yung base conjugate acid, acid conjugate base. We have another example here. Okay? So, we have acetic acid, CH3COOH, and when you react it with methylamine, it produces acetate ion and methylammonium ion. Okay? So, if we draw the mechanism, organic chemistry, the lone pair of nitrogen will be used to abstract the hydronium ion. Given this in mind, okay, with this in mind, sino yung acid, sino yung base? Okay. Sino yung Bl acid, sino yung Bl base? Susulat ko ulit yung definition sa taas. Okay, sino sa dalawa ang Bl acid, Bl base? Okay. So by the way, sa left side yung tawag na Bl acid, Bl base. Sa right side, ang tawag sa kanila, conjugate. Okay. So sa dalawang to, sino yung acid, sino yung base? Just look at the reaction in general. So si acetic acid ay blank, si methylamine ay blank. Okay. Sige, I'll keep the answers coming sa chat box. I think this is good news, no? Ano yung good news ko? magkakaroon na ng peace talks. Buti naman. Between Ukraine and Russia. Okay? So according to Renz and Kyla, acetic acid is the acid and methylamine is the base. Obvious naman na si acetic acid yung acid kasi may acid. Ayan. Okay? So siya yung bronzed lauric acid natin, while methylamine is the bronzed lauric base. Also, that can be confirmed na when you look at the partner of acetic acid, which is the acetate ion, paano mo uli sir malalaman kapag siya yung partner? Tignan mo lang yung structure. Kapag parehas, no? Nawalan lang ng H. Yun yung partner niya. So for acetic acid, if you look at the product side, nawalan lang siya ng H, no? Di ba may original H dyan? No, nawala. So ibig sabihin yun na walang H, it was donated, no? So that's why it's considered a bronzed lauric acid. Si methylamine naman, okay, same process. So originally, dalawa yung hydrogen niya dito. However, in the product side, naging tatlo na. Okay? So meaning, yung nawalang H ni acetic acid, kinuha niya. Okay? Ayun, ninakaw niya. Hindi naman ninakaw kasi pwede ibalik. Diba? Dahil sa reversible reaction. Okay? So kinuha niya yung hydrogen, tas binalik, no? Okay? Hindi katulad ng iba na hindi pa rin binabalik ang pondo natin. Anyway, nanood ba kayo debate kahapon? Sana nanood kayo. Okay? So, yun. Yung H, kinuha niya. Okay? So, ibig sabihin, methylamine is a base because it accepted the proton. Okay? So, yun. So, yan yung by just looking at the formula, no? By just looking at the equation, you can infer sino yung acid, sino yung base, no? Ano yung difference? Yung number of hydrogen lang. Kapag acid, mababawasan ng hydrogen. Kapag base, nadadagdagan ng hydrogen. Okay? So, yun lang yung shortcut dyan. Pag nabawasan ng H, acid yun. Pag nadagdagan ng H, base yun. Okay? So, now, we were able to successfully label yung reactants. Now, how about the products? Okay? Anong conjugate sila? Okay? So, si acetate ion, anong uri na conjugate siya? Conjugate acid, conjugate base. Si methyl ammonium ion, is it a conjugate acid, conjugate base? Dito na medyo mako-confuse ulit na. Which is okay lang naman. Okay? Conjugate base, acetate ion. Correct. Okay? So, tama si Miriam. Okay? So, conjugate base, etong acetate ion. Okay? Meaning, the methyl ammonium ion is the conjugate acid. Okay? Ang ganun. Tandaan, pag sinabi conjugate, that is if baliktad yung reaction. Okay? Yun yung pinaka-idea ng term na conjugate. So, if babaliktarin mo yung reaction, sino magbibigay ng H? Sino tatanggap ng H? Okay? So, if you do the reverse reaction, yung acetate, nadagdagan ng H. So, siya yung conjugate base. Also, in the same reverse reaction, yung methyl ammonium ion, siya yung nawalan ng H. So, siya yung conjugate acid. Okay? Basta may sinabing term na conjugate, babaliktarin mo yung isip mo. As if the reaction is reversed. Okay? Ayan. Another example. Kung kumukopya kayo, sige, screenshot niya. Ay, i-reverse o naman. Habang nagdi-discuss ako, natingin ako sa mga My Day. Nainggit ako sa isa kong FB friend kasi meron siyang upuan na nagmamassage. Alam mo yun sa, pag nasa SM ka, lalagyan mo ng 20 tapos i-massage ka. Pag natanda talaga, ganun na. Gusto mo na lang mga massage. Okay. Anyway, let's try this one. So, we have here acetic acid and water producing acetate and hydronium ion. Okay, tell me, sino yung acid, sino yung base, sino yung conjugate acid, sino yung conjugate base. I think ita-type nyo. So, this one is acetic acid. This is water. This is acetate. This is hydronium. Okay. So, identify nyo sino yung acid, sino yung base, sino yung conjugate acid, sino yung conjugate base. Okay. Sige. Antayin ko yung response nyo sa chat box. In fairness, buti nasundan nyo agad. Okay. Kasi alam ko last year medyo hindi agad nag-grasp. Okay. Pero don't be shy if may portions na gusto nyo i-clarify. Okay. Sige, so keep the answers coming muna sa chat box. Okay, let's check. Sabi ni Christine, BL acid, acetic acid, BL base, water, conjugate acid, hydronium, conjugate base, acetate. Okay. And I think yun din sagot ng iba, no? Yeah. Okay, so tama kayo. Very good. Okay. So, yung mga nasa left side, yun yung mga BL. Okay? Tapos yung mga right side, yun yung mga conjugate na. Conj yung aking abbreviation, ha? Ginaganon ko na lang. Nakakatamad eh. CONJ. So, this is your acid. Okay? So, meaning yung kapartner niya na si acetate, siya yung conjugate base. And yung water, since yung acetic acid ay acid, yung water ay magiging Bronsted-Lowry base. And yung kapartner niya on the other side, yung hydronium, siya yung conjugate acid. Okay? Ang ganun lang. Okay? So, you can simply tell kung sino yung conjugate acid, conjugate base na. Ito shortcut na lang. Shortcut to. Pag yan nadagdagan ng isang H, yan ay conjugate acid. Pag yan nabawasan ng isang H, yan ay conjugate base. Okay? Tingnan mo. Ito nabawasan ng H. So, conjugate base. Tapos, ito naman, nadagdagan ng H. So, siya yung conjugate acid. So, yun na lang yung shortcut ko. Okay? So, kahit di ako bigyan ng reaction, titignan ko na lang yung H. Pag nadagdagan, edi acid, conjugate acid siya. Pag nabawasan, edi conjugate base. Okay? Ganun lang siya ka-simple. Kasi may ganyan sa quiz, kaya sinasabi ko na. Okay? And anyway, we have another one. Ay, hindi. Kanina pa pala to. Ito yun eh. Actually, yun na yun. So that's the Bronsted-Lowry definition. Okay. The last one, we have the Lewis definition. Okay. So the Lewis definition was made by Gilbert Lewis. Siya yung gumawa ng Lewis structure. Okay. So, according to Lewis, a Lewis acid is a substance that can accept a pair of electron, while yung base daw, it can donate pair of electron. Okay? So, aking abbreviation dyan, Lewis acid and Lewis base. Ang Lewis acid ay LP acceptor, lone pair acceptor, and then kapag base siya yung lone pair, donor. Okay? And what happens when a lone pair accepts and when lone pairs are accepted and donated, what happens? There is a formation of a chemical bond. Okay? So ito yung medyo weird again. Kasi si Lewis definition, uh, sabi niya, in the formation of bond, meron din palang acid and bases. Okay? Kaya nga sinabi ko sa inyo last semester, especially to my students, I told them that all organic reactions are considered acid-base reaction because of Lewis definition. Basta may na-form na bond, may acid, may base doon. Okay. Yan yung pinaka-idea but nasabi ko last year na ang organic reaction ay acid-base lang in a sense. Yan ay kung naalala nyo yung nadi-discuss ko dati. Okay, pero yan yung pinaka-idea. So yun. And that's according to Lewis definition. Kung sino nag-donate ng lone pair, siya yung base. Kung sino yung tumanggap ng lone pair, siya yung acid. Okay? And this is common in organic compounds. Mas common siya nakikita sa organic compounds. Okay? But just for example, if you can see here, the OH is the base, the H plus is an acid because if this base donates lone pair to hydronium ion, a chemical bond is formed. Same with ammonia and acid na H plus. This lone pair can be used to create a bond. Okay? So ito lang yung new idea kay Lewis. There is a formation of chemical bonds. Okay? May nabubuong chemical bonds. Okay? So, yan ang ating tatlong definition ng acids and bases. So, let's look at this again. So, ito may lone pair. Pagdating sa product side, wala na siyang lone pair. So, ibig sabihin, siya yung Lewis base. Ito yung Lewis acid. So those are the three definitions of acid and bases that you really have to remember. No? So it is a requirement na kailangan kabisado nyo siya. Okay? So madali lang naman. Kapag Arrhenius, yung H plus donor, siya yung acid. OH minus donor, siya yung base. Okay? Kapag Bronsted-Lowry definition, kung sino nagdagdagan ng proton, siya yung base. Kung sino yung nabawasan ng proton, siya yung acid. Okay? And then may counterpart siya. Tawag doon, conjugate acid, conjugate base. Pag nadagdagan ng H, siya yung conjugate acid. Pag nabawasan ng H, siya yung conjugate base. Then lastly, for the Lewis definition, for the Lewis definition, kung sino yung nag-donate ng lone pair, siya yung base. Kung sino yung tumanggap ng lone pair, siya yung acid. And upon the transfer of lone pairs, you form chemical bonds. That's why this is most commonly used in organic reactions. Okay, so yun lang. Now, wala ba kayo napapansin sa ginagawa natin kanina pa? Kasi ako, gusto ko i-point out to. Tignan niya. Si water dito, tignan niya ha. Si water dito, base. Pero, dito sa reaction na to, acid siya. So, ano siya? Hindi niyo ba napansin yung kanina? Dito, acid siya eh. Pagdating dito, base na siya. So, ano si water? Balimbing ba siya? Politiko ba siya? Kasi paiba-iba ng sides eh. Yan. So, yan. Tama yung term na. So, water can actually act both as an acid and a base because it is considered amphoteric, no? Or amphiprotic, no? So, yan. So, yun yung something unique with water. So, pwede siyang acid, pwede siyang base. And because it has an equal tendency to be an acid and a base, that means the pH of water is 7, meaning siya ay neutral. So, sa lahat ng neutral, siya talaga yung neutral. Kasi pwede siya maging acid minsan, pwede siya maging base, at equal tendency. Okay? So, siya yung pinaka-neutral sa lahat ng neutral. Okay? Also, if we look at this, if we look at the property of water, no, makita mo talaga yung acid-base property niya. So, if we do autoprotolysis in water, meaning ng autoprotolysis is yung H2O, mag-split siya into two ions, na? So, the H plus and the OH. So, as you can see, for every mole of water, you will have 1 mole of H plus and 1 mole of OH. So, equal talaga yung tendency niya to be an acid and a base, na? So, that makes water very unique, na? That makes water neutral, na? And yun, napakalaking napakalaki ng effect niyan, no? Especially in biological species, no? Because sometimes water acts as an acid in biochemical reaction, sometimes it acts as a base, no? Kumbaga siya yung pinaka-versatile sa lahat ng compounds na around our inside our body. Okay? So again, the autoprotolysis, it just means that your water is in equilibrium na it produces H plus and OH minus. And since it is an equilibrium, it has a corresponding equilibrium constant. Okay. What's the equilibrium constant of the dissociation of water? So the dissociation of water into its ions, it has a K value of 1 times 10 raised to negative 14. Okay? So it has a value of 1 times 10 raised to negative 14. Siguro magtataka kayo, no? Sir, ba't wala yung H2O sa equilibrium na? Kasi again, yung liquids, we don't write them, di ba? Parang si Bruno yan, we don't talk about it na. So that's why yung H and OH lang yun as nakalagay sa equilibrium natin. Okay? So yun. And the product of H and OH concentration is 1 times 10 raised to negative 14. Since this is specific for water, so ito sa water lang talaga siya. So yung Kc natin, ginawa natin Kw, or the ion product constant of water, or K water. Ngayon, what's the implication? If the H plus and OH concentration are equal, then it is considered that the solution is neutral. Okay? While if mas marami kang H plus kaysa sa OH, that means you are acidic, and kapag mas marami yung OH kaysa sa H plus, you are basic. Okay? The solution is basic. Now, yung ating K value, it depends on the temperature. Okay? So if you remember the lecture na I gave last time, sabi ko doon that the K value is dependent on the temperature, no? So that is the reason, no, why yung ating food mabilis mapanis if mainit, and hindi siya mabilis mapanis if malamig, no? Because the K value changes. Okay? So for water, its ion product also changes. Okay? So you can see here at different temperature, the Kw increases, no? So nag-i-increase siya. Okay? So yan. However, in doing chemical reactions, everything are done in 25 degrees Celsius. That's why kailangan naka-aircon yung mga laboratory. Okay? So that we can ensure that the ion product of water is at least around 1 times 10 raised to negative 40. Okay? So, ganun lang. Okay, let's have some exercises. Ito, basic lang to. Exercise 1. What is the concentration of OH in in a HCl solution whose hydrogen ion concentration is 1.3 molar. Okay? Diba? Wala, paano yun? Binigay yung H plus concentration, pero yung OH hinahanap. So, that's very easy to answer. Okay? Paano? You write your KW. Okay? Because this relates the concentration of H plus and OH, right? So, ganun. So, pag binigay yung H plus, hinahanap OH, you write KW. Okay? Because doon mo makukuha yung kanilang relationship. So, now, what's KW? That's 1 times 10 raised to negative 14. Since we are looking for OH, we have to write an equation wherein yung OH yung hinahanap, right? So, OH is equal to KW divided by H plus. Okay? KW is fixed, so kailangan kabisaduhin nyo siya. It's 1 times 10 raised to negative 14. And the concentration of H plus is 1.3 molar. Okay, so we can just simply divide it so that we can find for the concentration of OH, which is, okay, buksan ko lang calculus. 1 times 10, negative 14, divided by 1.3. So, ito yung concentration ng OH, no? Okay. So, the concentration of OH is 7.69 times 10 raised to negative 15. 7.69 times 10 raised to negative 15. Now, can you tell me if this is acidic or basic? Basic kaya siya or acidic siya? Okay. Now, remember your H plus concentration is 1.3 molar. So, both are them in molar concentration. So, can you tell me kung siya ay acidic or basic? And then, bakit? Sige. Now, kung gusto niyo ng reference, ito. So, tandaan, kapag equal sila, as neutral. Kapag yung isa greater than the other, pwede siyang acidic o kaya basic. So, now, sige. Now, tell me if the solution is acidic or basic. And why? The solution is acidic. Now, bakit? Mas mataas po ang H plus value. Correct. Okay? Very good. Galing ah. Galing ko, maaga tayo matatapos. Okay? Kasi magagaling kayo. Or na-review nyo na siya in advance. Anyway. So, since our H plus concentration is greater than the OH, that means the solution is acidic. Okay? So, acidic siya. Okay? Now, ay, yun lang. Wala nang ibang problem. Ito. Wait lang, ayusin ko yung slides ha. Alam ko kasi yung kasunod dapat yun eh. Ay, hindi, tama lang. Anyway, so ganun lang ha. Iba pala yung nasa isip ko. Okay, so this one is acidic because the concentration of H plus is greater than the OH na. So just as what we solved earlier. Okay, so now, there is a more convenient way of determining whether a substance is acidic or basic. No? May mas madaling paraan, and that is the pH. Okay, pH or power of hydrogen. Now, we were able to discuss this in chapter 2 sa lecture. So, dapat may idea na tayo on how to do basic calculations. Okay? But anyway, I'll still guide you. So, yan. So, the pH or the power of hydrogen is a measure of acidity. And formula-wise, it is negative log of H plus concentration. Okay, the concentration must be in molarity. Now, di ba remember, sabi natin, kapag mas marami yung H plus, acidic siya. And then kapag mas marami yung OH, basic siya. Okay? Pag mas marami yung H plus, acidic. Pag mas marami yung OH, basic. Pero, tignan nyo, when it comes to pH, medyo kakaiba siya. Okay, the trend is reverse. Okay, acidic kapag less than 7 ang pH, pero basic kapag greater than 7 ang pH. Bakit? Kasi may negative sign. So, yun lang yung dahilan. Because of that negative sign, the trend is reversed. Pag lumalaki yung concentration of H+, what happens to the pH? Bumababa. Okay? And kapag bumababa yung concentration ng H+, tumataas ang pH. So, all of those, yung reverse trend na yan, that is caused by the negative sign. Okay? Yung negative sign yung may dahilan na bakit siya nagiging opposite yung trend. Okay? Basta tandaan, kapag acidic, less than 7. Kapag basic, greater than 7. Because I encountered some people na medyo confused pa rin. Okay? So, this is just a reminder if you are also confused. So, yan. Just a reminder that the trend is opposite. Acidic, if you have lower pH, pag mababa pH, mataas ang H plus concentration. Pag basic, mababa ang H plus concentration, mataas ang pH. So, the reason behind that inverse trend is the negative sign. Okay? And as you can see here on the table on the right side, we have different pHs for some common fluids at home. Okay? But actually, pwede nyo ito gawin sa experiment nyo. Okay? So for example, lemon juice has a pH of 2.4. So acidic yan. While yung ating ammonia, okay, ito yung mabaho na pinapaamoy ko pag nahihilo, it has a pH value of 11.5, meaning it's a base. O yung luha pala natin, base, basic pala siya. Try natin umiyak. Mag-quiz na lang. Try niya, tapos lagay niya sa pH paper. Tapos ilagay niya sa home lab experiment. Sir, iyak ko po yan. And so, kayo bahala. Basic pa na siya. Okay. Ano kaya meron sa luha? Alam ko lang maalat siya eh. Pero I'm not sure kung ano meron dyan. Okay, so kung gagamit kayo ng luha, edi you look for whatever is in it that causes it to be basic. Puno agad. I-move ko ngayon deadline this weekend. Okay. Anyway, kaya nyo yan. Alam ko medyo stress pero okay lang yan. Ganun talaga ang life. Okay. So yan. Pwede kayo pumili ng mga yan. O kung urine, kung gusto nyo umihi, kayo bahala. Okay. So yan. Pero ako ang sasuggest ko mga vinegar, ayan, orange juice, pwede. At saliva, pwede. pH 6 na. Pure water 7 o kaya alcohol. Wag naman may ng dugo Okay. Sa base, pwede mga carbonates, Ayan. So, pwede mga sodium carbonate, Cremil S, mga Alox. Ayan. Alam ko yung mga yan kasi acidic yung tiyan ko parata. Gaviscon, ayan. Mga Gaviscon. Patak nyo doon. Tapos tignan nyo kung anong kulay. Okay? So, also, di ba, parang napapansin nyo that the pH scale is up to 14, Okay. Yung 7, magigets nyo yan. Bakit siya equal to 7? Because if you place times 10 raised to negative 7, So basically, magiging 7 lang talaga yan. So kapag ang H plus mo ay 1 times 10 raised to negative 7, pH is equal to 7. Pero bakit kaya up to 14 yung pH scale? No? Bakit siya 1 to 14? May kinalaman yun sa KW. Okay? So remember, for the dissociation of water, this is your KW, right? And that is equal to 1 times 10 raised to negative 14. If we try to get the negative logarithm of the entire equation, so ano mangyayari? If we try to get the negative logarithm of both sides of the equation, ganito may itsura. Negative log of this will be 14. So yun yung reason bakit up to 14 yung pH value natin. Dahil lang yun sa negative logarithm of the KW. No? While itong H and OH, they will split up into two. Kasi rules of logarithm yun. Okay? When you apply logarithm to the product, they actually split up. No? So kung naaalala niyo yung algebra, log AB equals log A plus log B. Okay? So maghiwalay sila. So negative log H plus negative log OH. And you know that negative log of H plus is pH. Negative log of OH is POH. So meaning the sum of pH and the POH is 14. So yun yung reason bakit ang pH scale natin ay up to 14 lang. Okay? However, there are some compounds that exceed the pH 14. Kaya minsan may less than 1 pa nga na value. Okay? So those compounds are strongly acidic or strongly basic na. Okay? So yun yung mga ano, minsan nga may negative pa na pH value eh. Especially if sobrang daming hydronium ion concentration talaga. Minsan naman yung OH, POH, yung pH lumalagpas ng 14 kapag super basic na talaga ng compound. Okay? So tawag natin sa mga yun ay super acids at super base na nagbubum-burum-bum sila. Natin ginok namin yan sa prof namin. Sabi niya kasi super acid, tas kami di nag-bum-burum-bum base kami. Nag-walk out siya. Lenny Minaj. Nag-walk out teacher namin. Nagtampo kasi kapag siya nagjo-joke, kami nakatingin lang. Tapos kapag kami nagjo-joke, syempre tatawa kami. Pero in good terms naman kami. Sadyang lang, mas exciting ang buhay kapag may drama. Ganun ang buhay chemistry. Anyway, so yan yung reason ba't yung pH scale ay up to 14. Let's try these two problems here. Okay, basically, nagawa niyo na rin to sa lecture, no? Okay, but let's apply it here. So, the pH of rainwater collected in a certain region of the northeastern United States on a particular day was 4.82. Grabe naman yan. What is the H plus concentration of rainwater? Okay, so we are given the pH. We are looking for the H plus. No? If you recall your lecture, may tinatawag tayong antilog. No? May antilog tayo. Okay, if you cannot recall, remember this is the original equation, Px equals negative log of x. Pero, if you want to get the x, what you will do is to get the antilog of the px. No? So that's 10 raised to negative px. In the context of this problem, yung x natin ay h plus. No? Okay? So meaning, the concentration of h plus is equal to 10 raised to negative pH. We can just simply plug in 4.82 to get the concentration of H+. So, ganun lang siya ka-simple. Okay? So, alalahanan nyo yung nasa lecture, ha? Yan. 10 raised to negative 4.82. Saan yung mouse? Ayun. Negative 4.82. Okay, so that's the concentration of hydronium ion, and as you can see, it's greater than 1 times 10 raised to negative 7. So it is indeed acidic. No? And the pH is less than 7. So acidic nga talaga. So 1.51 times 10 raised to negative 5. Molar. Oh, do not forget the unit, ha? Baka makalimutan ng unit sa final answer. Next problem. The OH ion concentration of a blood sample is 2.5 times 10 raised to negative 7 molar. What is the pH of the blood? There's actually two ways to answer this. Dalawa yung way to answer this. Okay? Could anyone tell me ano kaya yung ways na yan? Paano ko kaya masasagutan yung second problem? Given yung OH concentration, hanapin ko daw yung pH. Ano sa tingin nyo pwede ko gawin? Sige, suggest kayo ng gagawin ko. Kunin ko po muna POH. And then, okay, so sige, sulat natin. Sabi ni, ni Renz, asan yung mouse? So, yung OH ko, pwede ko gawing POH. And then, from the POH, I can get the pH ko. No, pwede yan. And then, what else? Okay. Okay, so yan yung isang way. Ano pa kaya yung isang way? Using yung mga nakita nyo sa previous slide. Ano pa kaya pwede? Using nag-start siya sa letter E. Tama ba yung number ng underlines ko? Okay. Anyway. So, ang sagot doon ay equilibrium. Okay. The ion product of water. Okay. Pwede ko gawin yan. So, from OH, using KW, pwede ko kunin yung H+. And then, yung H+, gawin kong pH. Okay. Pwede yan. So, kung ano man piliin nyo, edi sige, go lang. But they should end up with the same answer, ha? So, let me try this first na, yung sinuggest nyo sa akin. So, I'll get the POH first, that is the negative log of the OH concentration. So, that's negative log of 2.5 times 10 raised to negative 7. Negative log. Times 10 raised to negative 7. So, 6.60. And then, using the pH plus POH equals 14. So, let me write here. Sorry, pH plus POH equals 14. I can solve for the pH as 14 minus POH. That's 14 minus 6.6. That's 7.4. Okay, so that's the pH of the blood, no? Which is nasa kaninang slide, no? Again, pH doesn't have any units, no? So just write the number. Okay, pwede rin naman yung OH to H plus concentration using KW, and then you can get the pH. I should end up with the same answer. Okay? So remember, KW is this. So H plus times OH. We are looking for the H plus. So Basically, that's Kw divided by the OH. And Kw is 1 times 10 raised to negative 14. OH is 2.5 times 10 raised to negative 7. Okay. Um, 1 times 10 raised to negative 14. And then 2.5 times 10 raised to negative 7. Okay. So that's 4 times 10 raised to negative 8. So that's the concentration of H plus. Then we can get the negative log na. So pH is negative log of the H plus concentration. So that's negative log of 4 times 10 raised to negative 8, which is 7 point, round off mo na lang, 7.40. Okay? So it's up to you, no? Which should you use? Pero ako, this is what I do, no? Pinakita ko lang yung dalawa para you know na you are not limited with one solution only. Okay? So, yan. Maganda kasing alam nyo yung mga paraan. So that whenever you face problems, you have means, no, to answer it. Okay? So, okay pa ba tayo dyan? Okay. Nasundan naman. Baka may question na. Let me know lang. Okay. Let's proceed now. Okay. If you can also still recall, in chapter 2, there are two types of electrolytes, right? Okay. Naalala pa ba? Chapter 2 sa lecture. So there are two types of electrolytes depending on the extent of the dissociation. When we say dissociation, this is the separation of ions into their ionic form na. So depende kung gaano sila na dissociate, you can have either strong electrolyte or weak electrolyte. For strong electrolytes, it is fully dissociated, okay, such as those in ionic compounds na. So metal, non-metal, if you split them, they are strong electrolytes, no? So they completely dissociate. While, let's say for some acids and some bases, they have weak electrolyte characteristic, meaning that the dissociation of ions is not complete. And usually in weak electrolytes, we have equilibrium systems. Okay? So, parati may equilibrium kapag weak electrolyte. Okay? For acids and bases, ganito din yung sistema na. We also have strong acids and then strong bases. We also have weak acids and weak bases. Okay? So, now, what are they? No? So, for strong acids, ito yung mga strong acids na alam natin. And as you can see, they are fully dissociated as denoted by a single arrow. No? Kapag single arrow, yan ay fully dissociated, meaning strong acid sila. Okay? Such as hydrochloric acid, which is muriatic acid sa bahay. Nitric acid. Okay? Ayan ay pinagbabawal ibenta. Dati pwede pa, no? But because of the restrictions, no, ginagamit kasi rin yan sa paggawa ng drugs. So, even kami, sa chemistry, nahihirapan din kami bumili niyan ng nitric acid ngayon. Okay? Pero yan. Ginagamit kasi siya not only in drugs but also in explosives. Okay? Kaya medyo mahirap bumili niyan. Okay? We have perchloric acid, HClO4. And sulfuric acid, H2SO4. Okay? So, those are some of the strong acids. Meron pang tinatawag na super acids, but they don't serve practical use naman. So, it's not worth mentioning. Okay? Wala naman silang ganap sa buhay. For weak acids naman, as you can see, all of them are governed by equilibrium arrow. Basta makakita ka ng equilibrium arrow, weak acid yan, okay, or weak base. Okay, some of them are hydrofluoric acid, probably because of the hydrogen bonding. Okay, remember that HF is a type of hydrogen bond. So, masyadong malakas yung hydrogen bond nila sa isa't isa that they don't fully dissociate. Okay. But even though hydrofluoric is a weak acid, it can still digest the flesh. No? So, siguro aware kayo dun sa mga videos on YouTube and in TikTok, no? Yung flesh-eating acid na sinasabi nila. So, kumbaga, ilalagay nila yung chicken, tapos matutunaw yung chicken. Ayan. So, pwede gamitin yung hydrofluoric acid for that. Nitrous acid, HNO2, is a weak acid. Okay. And this is bisulfate. Okay, so bisulfate anion is a weak acid. It is the second dissociation of your strong acid, hydrosulfuric acid. Na. And then yung water is considered a weak acid. Na. By the way, let me just reiterate this, no? Kasi kailangan natin to tandaan. That for sulfuric acid, the first dissociation is the strong, no? When I say first dissociation, yung isang H na natanggal, yun yung strong. But this one, this can further dissociate. Ito yun. Okay, yan yung second dissociation of sulfuric acid. Pero weak na siya. So, yung first dissociation, strong, but the second dissociation is weak. Okay? So, weak na siya. Basta tandaan, si sulfuric acid, 2 beses siya nag-dissociate because of the 2 H ions it possesses. Okay? The first is strong and the others are weak. Ayan. Hindi nyo naman kailangan kabisaduhin lahat, ha? Isipin nyo kung kabisaduhin lahat. For bases, ganun din. Typically, bases of metals are strong base, no? Yung mga base ng metal, strong sila commonly. But for the conjugate bases, okay, so sila yung mga weak. Okay? So weak na sila. You don't have to remember everything. Sometimes you just need to look at the arrow. So, if yan ay single arrow, strong yan. Kapag equilibrium, that's weak. Okay? So, in the conjugate acid-base pair system, okay, usually the H3O that is produced is the strongest acid that can exist in the solution. And your conjugate bases don't have enough they don't have measurable strength because of the product na H3O+. No? So sila yung pinaka-contributor sa acidity ng solution, and the same, it is the same as the OH ion. Okay, as the contributor for the OH. Yung ating mga conjugate base systems, wala silang ambag. Okay, kasi mas malakas yung kasama nila. Okay. So in this table, this is just the strengths of acids. So again, you don't have to memorize everything. Okay, basta you have to be familiar with some of them that are used in chemistry, such as acetic acid, formic acid, yan, ammonia, that's a base, and then hydrochloric acid, sulfuric acid. Okay, so again, no need to memorize. Another thing to keep in mind is that for strong acids, the dissociation is complete. Okay, so it fully dissociates into ions. So let's say you have HCl. When it reaches equilibrium, all of it are dissociated into ions. No? So wala tayong equilibrium system. Lahat sila naging product. But remember, in weak acids, there exists an equilibrium system wherein mayroon pa ring reactant and some amounts of the products. Okay? Lagi tatandaan yan. Kapag strong acid, fully dissociated sila. But for weak acid, they are in equilibrium. Meaning they are governed by equilibrium constants. Okay? So, yan. And this will be very important. No? Why? Kasi, when doing calculations, let's say you want to solve for the concentration or let's say the pH of the solution. For strong acid, the pH of the solution can be easily measured. Okay? You can just use stoichiometry. Let's say for HCl, asan yung mouse? Ayun. So let's say yung HCl mo 0.1 molar. That means the products are also 0.1 molar according to the stoichiometry. So ganun ka-simple na. So whatever the concentration of the acid is, using stoichiometry, you can tell the concentration of your products because they are fully dissociated. But whenever you encounter weak acids, ano gagawin mo? You have to do the ice table. Okay? Because keep in mind that when you have an equilibrium system, not all of them will be converted to products. Meaning, if you have 0.1 molar of this weak acid, you really don't have 0.1 molar of the products. Na? Because again, they are not fully dissociated. So it is less than zero point 0.1 molar. So the ice table will help you determine what those concentrations are. Okay? Anyway, so siguro bigyan ko muna kayo ng 5-minute break. Is it okay? So, kuha muna kayo ng lunch ninyo. Ako kasi medyo dry na yung throat. So, I need to get some water then. And so, I'll give you a 5-minute break na. And then, let's resume whatever we are talking about na. Okay, basta tandaan nyo lang ito. Okay, so 5-minute break muna because my throat is very dry. I will see each other at 12:08. Okay, so I'm back na. Pero you still have 1 minute. Mabilis kasi mag-dry yung throat ko lately. Siguro dehydrated lang ako. I don't know. Yeah. Anyway, so, yeah. So, let's go back na, no? Just as what I'm saying earlier, so if you have a strong acid, you can get the concentration of your products by stoichiometry. No? So it's very easy, very straightforward lang. But in case you have weak acids, no, you have to use ice table so that you can get the concentration of the products. Okay? So meaning, when you encounter problems, let's say pH problems, no, madali lang siya for strong acid, na. You can easily get the pH of the solution. But for the weak acid, in order to get the pH, you have to determine first the concentration of H plus using the ice table. Okay? Because if you have, let's say, 0.1 molar of the reactant, you don't technically have 0.1 of the product. Okay? So, hindi siya ganun. So, you have to do some algebra. Okay? So, let's do that. Na? So, these two problems are strong acid and strong base. Okay? So, I'll show you how to do this na. Okay? So, let's say, ito yung problem natin. What is the pH of a 2 times 10 raised to negative 3 molar nitric acid? So, all you have to do first is to show the dissociation of nitric acid. And nitric acid is a strong acid, na. A strong acid yan, na. So, you show the dissociation first. So, HNO3, it will dissociate into H plus and the nitrate, anion. Kapag sinabi kasing pH, okay, pag sinabing pH, you need to look for this, not this. Okay, because there are some students na ganun ginagawa na thinking na shortcut yon. Walang ganun. Okay. Iba kasi, uy, ito yung concentration, negative log ka. So, that could be wrong. Especially if yung number of H mo is not equal to 1. Okay? Or the number of H is not equal to 1. Okay? So, you have to get this first. Na? Okay? Not this. Okay? And again, since this is full dissociation, we can get the amount or we can get the concentration of the product. Okay? So again, if walang coefficient, meaning yan, tigwa 1 mole lang sila. Okay? So we can convert the molarity of nitric acid into the molarity of H+. Okay? So how can we do it? So you get the molarity of nitric acid and multiply it by the Stoich factor. Okay? So let's multiply it by the stoichiometric factor. So according to the equation, for every mole of nitric acid, you have 1 mole of H plus. Okay? So that's 2 times 10 raised to negative 3 molar times 1 over 1. So ganun pa rin naman. Okay, so 2 times 10 raised to negative 3 molar H plus concentration. But again, you have to be very careful, ha? Okay. Kasi hindi porket yan yung molarity initially, yan na yun at the end. You have to show the dissociation reaction first. And then since you have the concentration of H plus, then you can plug it into your pH. Na? So that's negative logarithm of H plus, negative logarithm of 2 times 10, negative 3. So the pH of the solution is the negative log and 2 times 10 raised to negative 3. So that's 2.70 if we round this off. Okay, so 2.70. So ganun lang na. Ganun na ka-simple. But again, hindi porket may concentration ka dyan, ipa-plug in mo na agad. So that's wrong. you have to show first the dissociation, no? So, even though hindi sinabi na gawin mo, gagawin mo siya. Okay? Because there are some problems like the next one, okay, na hindi 1-to-1 yung ratio nila. Okay? Let us answer the next one. Okay, so we have the concentration of barium hydroxide being 1.8 times 10 raised to negative 2 molar. We want to get the pH, no? And just as mentioned earlier, pwede nyo gawin from the OH concentration, you get the OH and then the pH. Pwede natin gawin yan. So first natin na gagawin is to write the dissociation. Required yan, ha? So, ibig sabihin sa problem set ng nitong topic na to, you have to write the equations always. Okay, so barium hydroxide is a strong base, okay? So, meaning it will fully dissociate into its ions. So, you have your 2 barium ions and 2 hydroxide anions. So, nagtataka siguro, sir, saan galing yung 2 hydroxide? Just look at the subscript na. You have to balance the atoms. So you only have 1 barium atom, and then you have 2 OH molecules. So that's why you have to write the coefficient 2. Okay? And then yung ions, they came from the reverse crisscross. So itong 2 galing dyan, so it's 2 plus. Itong 1 na to galing dito kay OH, so it's negative 1. Okay? So anyway, so look at this, no? The ratio of the concentration of barium hydroxide and the OH is 1 to 2. Okay? Ibig sabihin, twice yung concentration ng OH sa concentration ng barium hydroxide. So that is what I want you to be careful na. Hindi porket nakakita ka ng molarity, you just plug it into your calculator. No. Check first if yung coefficients nila ay 1 or 2 or something else. Okay? So, mag-iingat nun, ha? So, given that, let's solve first for the molarity of the hydroxide ion. So, we have the molarity of barium hydroxide times the mole ratio. So 1 mole of barium hydroxide will give us 2 moles of hydroxide anion. Okay. Basically, I need to multiply this by 2. So times 2 over 1. So 1.8 times 2, 3.6, diba? So 3.6 times 10 is a negative 2 molar yung concentration ng OH. Tama ba ako? Nagdududa din ako sa sarili ko. Times negative. Ayan, so 3.6 times 10 raised to negative 2. Okay? And then, since you have that, you have the OH na, you got the POH. Okay, medyo maraming steps nga lang. So that's the negative log of the OH concentration. Negative log of 0.032. So negative log of that. So 144. And then the pH can be obtained by obtaining 14 minus the POH. It's 14 minus 1.44. So that's equal to 12.56. Okay? So, ganun. So, again just be careful. Not because you have the molarity, you can just simply plug it in the pH or the POH equation. Okay? You have to be careful yung you have to be careful with the coefficients. Why po naging 0.32? Same lang yun as 3 points. Ay, oo nga pala, 36 pala. Ay, thank you. Namamahinga na yung utak ko eh. Gutom na. It's 0.36 pala. So, thank you for the reminder. 0.36. Yun. 144 pa rin naman pala. Okay, 144 pa rin. Okay. Okay. But anyway, baka kasi malaking effect niya kapag iba yung number. Ito, we have, sir, do we disregard coefficient of this formula or same po siya sa equilibrium? Hindi mo siya i-disregard. No? You have to consider it. That's why we did this. No? Ito, kaya ginawa natin ito. Because dito yung galing. Okay. So yung mga coefficients, they are very important. No? Because they will tell you the correct amount of your ions. Okay? So hindi sila i-disregard. Okay? Diba sa equilibrium, kinonsider din natin yung coefficients. Na? So ganun din dito. Okay? Again, for strong acids, strong bases, the pH calculation is very easy. All you need to do is to show the dissociation, the full dissociation into ions, and then check mo what are their coefficients. Okay? And yung coefficients na yun, you can use that to convert the molarity of one substance to the molarity of your either H plus or OH ions. Na? So, madali lang siya. But how about weak acids and weak bases? Okay? So again, pag strong, stoic lang, and then makuha mo na pH or POH. But for weak acid, you have to do equilibrium calculations. You have to use ice table. Okay? So again, let me just remind you of the dissociation. Okay, so for weak acid, we will abbreviate weak acid as HA. So when our weak acid is in aqueous solution, it produces hydronium ion and your conjugate base, your A-. Okay? So removing H2O, since hindi naman siya kailangan sa equilibrium, we can write the equilibrium constant Ka equals the product of H plus and A minus divided by HA. Okay? So basically, it's the concentration of the products divided by the concentration of the reactants. Okay? This equilibrium constant is for acid. That's why we write Ka. Okay? So Ka kapag acid. Kapag base, edi Kb. Kapag Kw, edi water. Okay? So, ganun mga pinagagawa namin sa life. Sa next session natin, meron pang tinatawag na KSP. Okay? That's a solubility product. Okay? Solubility product. Okay? Meron pa nga tinatawag na KF, a formation product. Marami pa yan. Okay? So, yan. So, basta K, it tells you that it is an equilibrium. Ka meaning it is for acid. Okay? So, that's the equilibrium constant for the acid. And as I said last time, sa lecture then, if you still remember, yung ating K, may value yan. No? And they are actually posted here in your canvas. If we go to the modules, okay, so if you check the module, chapter 4, you have your pKa and KSP values. Okay? Bakit kaya URL doesn't exist? Anyway, so pwede naman na ito. Click nyo na lang yan. Medyo di ko rin alam ba't ganun yan. So this table shows you the corresponding acid dissociation constant. Huwag nyo kakabisaduhin. Hindi kinakabisado yan. Okay. So yan. This is your, let's say, acetic acid. The Ka value is 1.75 times 10 raised to negative 5. Let's say you have ammonia. So the Ka value is 5.69 times 10 raised to negative 10, etc. Okay. So, all of them, lahat ng K values natin, nakatabulate. Okay? So, yan. Ito din, meron din pala sa PowerPoint. Okay? So, yan. The equilibrium dissociation constant for acids are already tabulated. Meron din sa base. No? So, we call that Kb for the base. Okay, so example here, we have ammonia plus water, it produces these products. Okay, since ammonia is a base, so we write Kb. At ito naman yung mga K values for the bases. Okay, again, di yung kinakabisado, tinitignan lang yan. Okay, so ayan. So since you know that in getting the pH of weak acids and weak bases, you have to do ice table calculation or equilibrium calculation. Okay, so just like what we did in the lecture, you have to write an ice table, and then after writing the correct ice table, we solve for the value of x, either with the help um, of your calculator or the quadratic equation, but I will show you a shortcut later. Okay, may shortcut pa yung mga tinuturo kong shortcut. Okay, and then after that, since once you've found the value of x, you can determine the concentration of all the species by plugging the x value in your equilibrium expressions. Okay, so yan. So same lang ng ginagawa natin sa lecture. So, long method muna tayo, but later ituturo ko yung shortcut, ha? So, pag nalaman nyo yung shortcut, nako, ang dali-dali na lang ng life. Yung mga shortcut na tinuturo ko, meron pang shortcut yan. Anyway, so let's do this, no? So let's say we want to calculate the equilibrium hydronium ion concentration of 1.2 molar nitrous acid, no? Not only the hydronium ion concentration, but also the pH. So let's try that. So given the equation, nitrous acid is a weak acid, so it will dissociate into H plus and the anion, okay? The conjugate base, NO2 minus. Okay? So you just write yung mga important ions or important species that are written in the K expression. So that will be the HNO2 kasi aqueous siya. So hindi ko na isusulat, ha. So important yung HNO2 kasi aqueous siya. And then you have your H3O plus and then your NO2 minus. Okay, we just disregard the water because we don't write liquids, right? And then ano pa yung mga sinabi ko in the lecture, if especially to my lecture students here. Initial, kung ano yung sinabi sa problem, ilalagay mo siya sa table, right? So sabi dito, we have 1.2 molar nitrous acid. So ibig sabihin, the concentration of HNO2 is 1.2 initially. How about the products? Ano kaya meron sa products? Do they have certain value or zero sila? Ano kaya sa tingin niyo? 1.2 din ba sila or zero sila? Or something else? Ano sabi ko last time? Pag walang sinabi na initial concentration, zero muna, okay? So, zero muna. Kasi walang sinabi. Ang binigay lang sa atin yung HNO2. Okay? Yes. So, tig zero muna sila. And what we know, di ba, na-discuss natin yung direction of reactions, right? Naalala niyo pa ba? So, in the direction of the reaction, kung saan yung zero, dun pupunta yung reaction. So, meaning sila yung dadami, and then the other side of the reaction will decrease. And now, my question to you is, sino yung dadami? Yung products, yung reactants? Just looking at the table. Sino yung dadami? Is it the products or the reactants? Okay. So, it is the products. Okay. So, meaning, the change for the products ay positive. Okay. So, for the products, that's positive. And then for the reactant, that will be negative. By how much yung change? By how much will they change? Ang sagot ay, gano'ng karami yung magbabago? Ang sagot ay, ang sagot doon, I don't know. So, ganun. Pag tinanong sa inyo, gano'ng karami magbabago? I don't know. Because I don't have any data pa. So, you just write X. Okay? So, ganun ha. So, how much will change? I don't know. So, just write X. And again, just keep in mind, yung nasabi natin last time, if you have coefficient, you have to include it in your change. Na? Because it must be proportional with the number of moles. Let's say, sabihin natin, 2 to, di lagyan mo ng 2x. Okay? So, ganun. And then, for the equilibrium row, all we need to do is to combine the initial and the change. So, that will be 1.2 minus x. 0 plus x is x, and then 0 plus x, also x. Tapos, ano na gagawin? You have your equilibrium expressions. Now, you have to plug them into your K equation. Okay, plug in natin sa K. Okay, so what's the Ka for our equation? So that will be H3O plus NO2 minus, and then nasa baba yung HNO2. Okay, nasundan naman to na. Okay, ayan. So, products over reactants. And then your Ka, edi 7.1, 7.1 times 10, negative 4. That will be equal to H3O, what's the expression? X. NO2 minus, what's the expression? X then. Okay? And then yung HNO2, that will be 1.2 minus X. Okay? Tapos ano na susunod na mangyayari? Algebra. Okay? So algebra na tayo. So I have to transpose this 1.2 minus X on the other side. So ito, rewrite ko na lang Kasi kapag transpose ko sa dyan, hindi na kasya. So pag flip ko na lang sila. I-flip ko na lang yung equation. So I have x squared here from there, and then 7.1 times 10 negative 4. 1.2 minus x. And then ano gagawin ko? Transpose, no? So, gamit ako ng blue to show na ita-transpose ko siya. Yan. By the way, kung kaya nyo ako unahan, sige lang. Just write the answer at the chat box. Dadaldal pa ako 7.1 times 1.2. What's that? 7.1 times 10 raised to negative 4 times 1.2. 852 times 10 raised to negative 4. Minus 7.1 times 10 raised to negative 4. X. Huwag makalimutan si X. Yan. And then, you have your quadratic equation almost okay na siya. But you have to arrange it in this manner. Ax square plus bx plus c equal 0. So, kailangan i-arrange mo siya ng ganyan na. So, lipat ko na lang both sides on the left. Okay? So, as you transpose them to the other side, yung sign nila magbabaliktad. Right? So, be careful, ha? So, ano na? So, you have your x square plus 7.1 times 10 raised to negative 4 minus 8.52 times 10 negative 4 equal 0. And then what? Now, you identify what are the A, the B, and the C. So, ano si A, ano si B, ano si C. As I said last time during our lecture, kung ano coefficient ni x square, yun yung A. Okay? So, 1 lang yan. Kapag wala nakalagay, 1. May nakalimutan ako. Yung x. Sabi ko, huwag kalimutan si x eh. Ayan. Okay? So, yung coefficient ng x square is 1. Kapag wala nakalagay, edi 1 talaga yan. Okay? And then for b, that's the coefficient of x, which is 7.1 times 10 raised to negative 4. And then for c, that is yung number lang, including the negative sign. Ha? So that's negative 8.52 times 10 raised to negative 4. And then what we will do, yung tinuro ko sa inyo last time, no? So after identifying A, B, C, you get your calculator, and then you solve for the quadratic equation. Okay? Ayan, nasolve na ni Kyla. Sige, let's go to your calculator. Just go to mode, and then press equation. And then, yung x square, ax square plus bx plus c. For class whiz people, ang itatanong sa inyo is yung polynomial, and then number of degree 2. Okay? Kasi naka-x square tayo. So we choose degree 2 or ax square. So the coefficient of A is 1. Coefficient of B is 7.1 times 10 raised to negative 4. And the concentration of C, concentration. The value of C is negative 8.52 times 10 raised to negative 4. Sino yung nandito na? Please press the like button. Like, share, subscribe. Press nyo na lang. Si Kyla meron na. Si Christine, Adrian, Richie. Okay. So, ganun na. So, just press those numbers. 1, 7.1 times 10 raised to negative 4. And negative 8.52 times 10 raised to negative 4. So, since square ito, naka-x square siya, you have two roots, remember? Okay? Dalawa yung root. Kasi according to math, kung ilan yung ilan yung degree ng polynomial mo, ganun karami yung roots. Okay? So, meaning we have to press equal sign twice. No? So, the first root is 0.028. Gawin ko na lang 29. Okay. Sige na nga, kopyahin ko na yung apat na digits. 0288. Okay? So, the first root is 0.2, 0288. Okay. So, that's the first root, 0.0288. And the second root is, the second root is negative 0.0295. Okay, So again, kung ilan yung iyong roots, ganun karami. Kung ilan yung degree mo, ganun karami yung roots. Okay? Sana all may degree. Okay. So x1, x2. Now, given the two roots, ano yung gagamitin nyo? X1 or x2? And then tell me why the other one must not be used. Okay, sinabi ko sa lecture yan. Ano ang gagamitin at bakit hindi pwede gamitin yung isa? Si Kyla may answer na. So, 0.029 daw or 0.0288. Bakit yon? Bakit hindi yung negative 0.0295? Bakit hindi ko gagamitin yung x2? Kasi it should be lower than 1.2. What else? Okay. Now, tama naman yun. Isa yun sa criteria, no? Na yung x value mo must be lower than the initial concentration. What else? Bakit hindi pwede yung negative 0.0295? Negative 0.0295. Kasi, ang sagot ay okay, the more concise answer is walang negative na concentration. Yan, walang negative na concentration and correct yan na kapag yung negative yung plug-in natin dito, negative yung amounts nila. Tama yun. Okay. X1 po kasi X2 mas malaki. Okay. Kasi walang negative na equilibrium. Yan lang. Okay? So, whenever you face that dilemma, no, na, hala, sino gagamitin ko dito? Yung isa positive, isa negative. So, gamitin mo yung positive. Yung negative, you just discard it because if you plug it into your equilibrium equation, ano yan? Bawal yan. Walang negative na concentration. Okay? Paano naman kapag parehas positive? So, if yan ay parehas na positive, you just choose which is lower than the initial concentration. Okay? So, pili ka lang ano yung mas lower sa initial concentration. Okay? Ayan. Given that, we can solve for the equilibrium concentration. So, we know that X is 0.0288 molar. Okay? So, plug in ko lang. So, 1.2 minus 0.0288. So, this is 0.0288 molar. 0.0288 molar. And ito ay 1.2 minus balik natin sa original yung calcu ha. So let's clear na lang. So 1.2 minus 0.0288 1.1712. Okay? So, yun yung sinasabi ko earlier, no? That you cannot just use stoichiometry when it comes to weak acids or weak bases, no? You really have to do ice table. Okay? Wala ba audio? Hello. Okay na. Baka nagalaw ko kanina. Minsan kasi nagagalaw ko rin. Okay? So anyway, ayun na. So, ganun lang. So yan, you have your hydronium ion concentration. But what about the pH of the solution if asked? Pag tinanong kayo, what's the pH of the solution? That is the amount of your H3O. Okay? Hindi ito ha. Ito. Okay? So, the H3O yan. Kasi I have some students na minsan nagkakamali. Okay lang naman. Okay? But basta hopefully makorek siya next time. So, ito yung gagamitin natin. Okay? So, the pH of the nitrous acid solution is, okay, that's negative log of 0.0288. So, negative log of 0.0288. So, that's 1.54. Okay? So, yan. So, ganun ha. So, whenever solving for the pH of weak acid, you just don't plug in the concentration you found, no? You have to do ice table calculation. Sige, we have a question. Kasi ang is ang question, ba't hindi pH 3O plus, no? Ang pH kasi, sorry, ang H3O plus ay analogous na rin with H plus. So, same lang sila actually. Kaya di ba minsan makikita mo sa textbook, nakalagay H3O, tapos mamaya bigla naging H plus. Same lang yan. Okay? Sa ganun. Yan. So, imagine nyo na lang yung magiging quiz nyo dito, no? Na-imagine nyo na ba? Ano na-imagine nyo? Puro ganito? Sabihin, sir, kailangan ba lahat na lang may ice table? Yes. Pero, may shortcut akong ituturo. Okay? Ito natutunan ko to sa review center. Okay? Matutuwa kayo kasi kapag nalaman nyo siya, super dali na lang pala mag-solve. Okay? Promise. Okay? Kasi as you can see, no, even though I gave you an idea on how to lessen the use of quadratic equation. Okay, calculator na yung sumasagot ng quadratic equation natin. But there is another technique that we can employ. Okay. So what's that? We call that the small x approximation. Okay. So we call it the small x approximation. Small x approximation. Okay. So this technique is used so that we don't need to make an ice table anymore. Actually, kahit di ka na gumamit ng ice table. Okay? So, when can you use this technique, the small x approximation? First, you have to divide the concentration of your reactant by your equilibrium constant K. So, i-divide mo yung concentration divided by the K. And if the ratio is greater than 1,000, you can do the small x approximation. Okay? So, paano yan? Let me show you. By the way, kung hindi ito satisfied, if this is not satisfied, then you have to do the quadratic equation, yung ginagawa natin. Okay? So, yan. So, again, you just divide the reactant divided by the K. If that's greater than 1,000, then you can do this technique that I will show you later. Pero if the ratio of concentration and the K is not greater than 1,000, then you have to do quadratic equation. Turo ko sa inyo yung technique. So look, our answer is 1.54. Let's check whether we can apply the small x approximation here. Ano sabi ko? You divide the concentration of the nitrous acid and the Ka. So I will call the acid HA, no? Di ba yun yung tawag natin kay acid, no? So instead of writing HNO2, I will just write HA. So i-divide ko si Cha kay Ka. Okay? So tignan ko if that's greater than 1,000. Ay, ulit ng concept. Ito. Again, bago tayo tumuloy. Divide mo muna yung concentration ng reactant by K. If greater than 1,000, then follow nyo yung gagawin ko. Okay? So ito, going back to the same problem, di-divide ko yung concentration ng acid kay Ka. Titignan ko kung pwede gamitin yung technique na ituturo ko sa inyo. Okay? So, di-divide ko si concentration of acid, si Cha, okay? So, 1.2. And then yung Ka, di-divide ko siya, no? So, what's the ratio? Kunin natin yung ratio. Oopsie. So, that's 1.2 divided by 7.1 times 10 raised to negative 4. 1,690. So, it's greater than 1,000. So, ibig sabihin, pwede si small x. Okay? So, ganun. So, again, ano sabi ko? Divide mo muna si concentration ng reactant sa equilibrium constant. If that's greater than 1,000, pwede si small x approximation. Yung ituturo ko ng shortcut. Okay? So, ano ba muna meron sa small x approximation? Okay, balik tayo dito sa original solution natin. So, looking at this specific region sa ating solution, okay, looking at this, no, ang reason why we did quadratic equation is the minus x, no? Ito yung dahilan bakit may quadratic equation. Kasi kung wala itong x na to, we can just get the square root, di ba? Kunin mo lang yung square root, may answer ka na. But because of this x, no, nagiging quadratic equation patuloy. Parang napapahirapan pa tayo lalo, right? So, yun yung goal ng small x approximation. If ang ratio ng concentration ng acid and the Ka is greater than 1,000, what you can do is just assume that this minus x term is very, very small. Okay? Pwede mo i-assume na very, very small siya to the point na pwede mo na siya burahin. Ano mangyayari? Pag binura mo na yung minus x sa denominator, you don't need to do quadratic equation anymore. You just need to get the square root. Okay? So, ganun yung pinaka-idea niya. So, let me just copy this na. So, di ba, ito yung Ka natin. So, concentration ng H+, NO2 minus, HNO2. And 7.1 times 10 raised to negative 4. Ito, x times x. Then divided by 1.2 minus x. Ang pinaka-goal netong shortcut na ituturo ko is that when the ratio of acid and the Ka is greater than 1,000, this minus x term here below can be omitted. And what will happen if you omit that? Ano mangyayari? Wala ka ng quadratic equation. You can simplify this as x squared equals 7.1 times 10 raised to negative 4 times 1.2. And to get x, that's the square root of 1.2 times 10, 1.2 times 7.1 times 10 raised to negative 4. Diba? Wala ka ng quadratic equation. And that will happen if small x approximation is possible. Okay? Again, before I continue with the solving, so originally may minus x dyan, no? Yung galing yun sa ice table. May minus x. But since the ratio of acid and the Ka is greater than 1,000, I can just simply delete this part. Okay? And upon deleting that, yung minus x, I will just have an equation that is x squared equals 1.2 times the Ka. And then to get the x, you just need to get the square root of the product. Para mas madali nyo makabisado, x is square root of was 1.2. That's the concentration of your acid times the Ka. So, to find the x lang pala, you just need to get the square root of tsaka. Okay? Yun yung pinaka-shortcut natin. So, instead na mag-quadratic ka, para makuha mo yung x mo, gawin mo, kunin mo na lang square root ni tsaka. What's tsaka? Concentration ng acid times its Ka. Okay? So if you do that, we will end up with the same answer as what we solved earlier. Okay? Let me show you. Okay. So kunin natin. So kunin natin ang square root ni tsaka. Nasaan yung mouse ko? So ano yung concentration ni Cha, no? So 1.2. Ano si Ka? Si Ka ng acid, 7.1 times 10 raised to negative 4. Well, look at our answer. Di ba ito din yung na-solve natin kanina? However, rounded off siya. 0.029. Ito, pag ni-round off mo, ano yan? 0.029. So, yun yung pinaka-goal ng small x approximation. Para hindi ka na mag-quadratic, just get the square root of tsaka. And by getting the square root of tsaka, you have the x ng equilibrium. Okay? So, yan. So, yan yung concentration ng acid. And then, just get the negative log. May pH ka na. 1.53. Ang nakuha natin kanina, 1.54. So, same lang. Okay? So, yun yung shortcut na. Yun yung shortcut ng lahat ng shortcuts. Okay? So, that's small x approximation. Whenever you meet this criteria, the ratio of acid and the K is greater than 1,000, you can just simply omit the minus x term in the denominator. And then by omitting the minus x term in the denominator, the x can be calculated as the square root of the concentration of the acid times the Ka, or square root of tsaka. And then you will have your x. Okay? So, yan. This will not work if the ratio of the acid and the Ka is less than 1,000. So, hindi siya gagana. So, kailangan i-check mo muna ito divided by ito. Okay? So, bigyan ko pa kayo example. Okay, para mas makita nyo na, oo nga, no, mas madali pala yung square root of tsaka. Okay? Ito, hindi to applicable eh. Ito, solve nyo na lang, no? Square root of tsaka not applicable. So, hindi pwede dito yung square root of tsaka. Okay? Pero dito, pwede ba dito yung square root of tsaka? Let's try. Sige, let's try here. Tignan natin kung pwede dito yung square root of tsaka. Okay? So, we get the concentration initial, okay? Concentration of your reactant initial divided by the Ka. Sorry, this is Kb pala. Ammonia yan eh. So, that's the base. Okay naman yan. So, either Ka or Kb. Okay, basta K. So, that's a typo. So, that's 0.075 divided by Kb, 1.75 times 10 raised to negative 5. Kunin mo yung ratio. Tignan natin kung applicable yung shortcut na ituturo ko. Okay, so that's 0.075 divided by 1.75 times 10 raised to negative 5. Ayun, applicable kasi this is greater than 1,000, no? 4285. Shortcut applicable. Okay? So kapag sinabi ko shortcut applicable, I can just remove the minus x term in the denominator, no? So ganun. So I will fill the ice table as is, okay? So ganun pa rin. So fill it as is, okay? The concentration of ammonia is 0.075. Ammonium ion and OH, walang sinabi. So since we don't have any products, the change for the product is positive. And then for the reactant, that's negative. So at equilibrium, you just combine the initial and the change. So 0.75 minus x, and then x. Let's write the K. So that's Kb. Base to eh. So na-typo lang ako kanina. So that's the concentration of ammonium ion, hydroxide anion, and ammonia. You plug in the equilibrium expressions. Okay. So 175 times 10 raised to negative 5 equals x times x divided by 0.075 minus x. Di ba sabi natin shortcut applicable? So what does that mean? Yung minus x term, burahin mo na lang. Okay? So you just omit the minus x term. Kasi the shortcut is applicable. Asan yung mouse? Sorry. Okay, so I'll just remove the minus x term. So therefore, I can use the shortcut. No? So that will be 1.75 times 10 minus 5 times 0.075 equals x squared. To get x, I just need to get the square root. No? Ayan. The square root of 0.075 times 1.75 times 10 raised to negative 5. So this is the x value, 1.14 or 1.15 times 10 raised to negative 3. So yun na yun. So 1.15 times 10 raised to negative 3. Ito na rin yun. So 1.15 times 10 raised to negative 3. And this one, so that will be 0.075 minus 1.15 times 10 raised to negative 3 or 0.074. Okay, so those are their equilibrium concentrations. Okay, makita nyo hindi na ako hindi na ako nag-quadratic na. I just obtained the square root, no? Because the shortcut is applicable. Okay? And I want you to master this. That's why sa next meeting natin, we will answer more problems. Baka inisip nyo, diretso agad tayo sa next topic. No? Hindi. We'll answer more problems pa so that we can really reinforce the use of the shortcut. Okay? So I have a worksheet for this chapter. Although di ko pa siya na-upload sa Canvas. Mamaya na lang siguro after kumain. Pero gusto ko ngayon pa lang isabuhay nyo na yung square root of Chaka. Super laking help nun when it comes to quizzes. Okay? Ganun sinasabi ko sa mga bata ko. Okay? Sabi ko sa kanila, kapag mag-answer ka ng multiple choice, kunin mo yung ratio ng acid divided by the Ka, and if they are greater than 1,000, then the x value is just the square root of Chaka. So don't worry, we'll answer more problems related to that next meeting. So this is the worksheet which I am yet to upload in Canvas. Yan. Sasagutan natin itong mga questions na to. Okay? Yan. Ay, kulang ata to. No? Dadagdagan ko pa to ng Dadagdagan ko pa ng problems. Okay? So anyway, So, dagdagan ko na lang yan ng problems. Ayun. You can also try this sa mga equilibrium problems nyo last time. Okay. Pero anyway, so we will reinforce this shortcut next meeting, ha? So, yun, sagutan natin yung mga na-leave kong items such as this one and this one. Okay, so we'll continue this next meeting. Okay, and yan. Marami pa tayong ganap next meeting na. So, sige, yan na lang muna for now. And I hope you learned something. Okay, especially sa application ng equilibrium when it comes to acid and bases, and of course, the definition of acids and bases. Huwag nyo kakalimutan yung square root of Jaka kasi gagamitin natin siya next meeting. Okay? For now, yun na muna. Okay, so thank you and I'll see you again next time. Okay, ingat parate. Again, alert level 3 na tomorrow. Sorry, alert level 1 tomorrow. So, mas maluwag na yung ating biyahe-biyahe. Pero mag-ingat ha. See you next time. Bye-bye.